Something emerged from behind the sun on November 1st, 2025. And what scientists saw left the room quieter than anyone expected. For months, the world had been tracking 3I/Atlas, the third confirmed visitor from beyond our solar system. We watched it approach, we watched it descend toward the sun, and then, like every interstellar object before it, we expected the story to fade into routine observation. But that didn't happen. Instead, there were 72 hours of absolute darkness. 3 days where every telescope, every observatory, every satellite lost sight of the object as it vanished behind the sun's blinding glare. No updates, no images, just a silence thick enough to feel intentional. When 3I Atlas re-emerged, it was different. Not slightly different, not a bit off, fundamentally different. Before we get to what changed, let me ask you something. Not as a narrator, but as someone who's been staring at these data drops for months. What would you do if you saw something that contradicted everything textbooks say about interstellar objects? Would you publish it immediately? Or would you hesitate? NASA hesitated. And that hesitation is where this story begins. On October 2nd and 3rd, nearly a month before perihelion, as 3I Atlas passed just 29 million kilometers from Mars, NASA's Mars Reconnaissance Orbiter pointed its most powerful camera at the visitor. The HiRISE instrument, capable of resolving details far sharper than anything Hubble ever returned for Oumuamua or Borisov, captured a full set of images from a side angle no Earth-based telescope could match. These images were taken over 40 days ago. And as of November 15, 2025, they remain unreleased. Think about that. We have the closest, clearest, most revealing photographs ever taken of an interstellar object. Data that could show the true nucleus size, the geometry of the strange sunward structures, the shape of its tail. Yet they're locked behind a notice marked NASA-wide news, requiring special approval for release. Meanwhile, HiRISE continues releasing new Mars images daily. Craters, dunes, dust storms, business as usual. But the 3I Atlas images? Nothing. Not a single pixel. Why treat this object differently? Why isolate these images from routine uploads? Harvard astrophysicist Avi Loeb has been pushing publicly, and increasingly bluntly, for NASA to release the data. His frustration isn't emotional, it's procedural. These are time-sensitive observations. The object is moving away from us now. Every day we don't have the data is a day lost for analysis, coordination, spectroscopy, and follow-up tracking. But the silence continues. Now, let's return to the moment of reappearance. Ground-based telescopes captured 3I Atlas after it cleared the sun's limb, and what they saw did not match what went in. Back in July, Hubble observed an unusual anti-tail, a structure extending toward the sun, not away from it. That alone was strange, but not unheard of under specific viewing angles. But after perihelion, after the highest heating, after the object should have fragmented, dimmed, or dispersed, the structure became more complex, more pronounced, more symmetrical. That's not how comets behave. That's how engineered systems behave under stress. The first amateur images released online showed multiple jets, at least 6 or 7, some pointing sunward, others forming unnatural geometry. And surrounding all of it was a growing halo expanding nearly 500,000 kilometers across. This isn't a subtle anomaly. This is a pattern. And here's where the missing NASA images matter. HiRISE had the perfect vantage point. While Hubble only captured a nearly edge-on view, HiRISE would have shown the three-dimensional structure, the true orientation of the jets, the depth of the anti-tail, the core brightness variation. In other words, the part of the story no one wants to show us. The official explanation? A government shutdown, a delay in communications, internal processing. But the shutdown ended days ago, and the images remain missing. We are expected to believe that the clearest photographs of an interstellar visitor during the most unusual phase of its behavior are simply pending review. And yet the blurry post-perihelion images from amateur observers keep surfacing, showing features that don't fit conventional models. So let me ask you again, if everything about 3I Atlas were normal, why are the highest resolution images the only ones being withheld? Why did the object re-emerge brighter than before? Why did its tail shift direction, toward the sun rather than away? Why does the structure look more organized instead of torn apart? Objects don't pass behind the sun and come out improved, unless something happened back there. Something none of us were supposed to witness. This is only the beginning. And what comes next is stranger. For weeks, most people watching the 3I Atlas story assumed the agencies had everything under control. A visitor from another star system, a few unusual observations, a complicated solar pass, nothing the experts couldn't explain in due time. But there was one scientist who refused to accept the quiet, Avi Loeb. If you've followed interstellar research at all over the last decade, you know his name. You may agree with him or not, but he has one quality the rest of the field seems terrified to display. He asks questions out loud. When the data doesn't add up, he says so. When a pattern breaks the model, he points it out. And when NASA sits on images of the closest interstellar object in human history, he does not shrug and wait. According to him, the delay is not normal, not procedural, not scientific. It is a warning sign. Loeb's first public statement came subtly, a short note released the day after perihelion. It read almost like a nudge, as if he was testing whether anyone else noticed. Images from high-rise should be released promptly, time-sensitive. 2 days passed, nothing. Then he went further. Science cannot function when essential observations are held back. These images belong to the entire scientific community. And finally, the line that made several people inside NASA distinctly uncomfortable. If the data contradicts the standard explanation, delaying its release does not make the data disappear. Think about that. He wasn't asking for the images. He was reminding them that no amount of silence will erase whatever high-rise captured. That kind of language doesn't come from a scientist who's confused. It comes from one who knows the patterns better than anyone and recognizes when a pattern breaks. But here's the part most viewers don't see. Loeb isn't speaking from ignorance. He already saw something, not the high-rise images. Those remain locked away. But on October 31st, just 2 days after 3I Atlas whipped around the sun, a small independent network of telescopes reported something NASA did not acknowledge, a deviation in the object's trajectory. Not large, not spectacular, but measurable, a non-gravitational acceleration that didn't match the expected outgassing curve. Loeb addressed it indirectly during an interview. Anomalous acceleration must always be treated carefully, but when the data is incomplete, when images are withheld, interpretation becomes nearly impossible. Translation: I see a red flag. Why aren't you letting me check it? Meanwhile, NASA continued posting routine imagery, dust storms on Mars, a harmless glacier scan, a ridged crater, as if nothing noteworthy was happening. Not one mention of 3I Atlas, not one update on the missing dataset. But someone inside the agency slipped. On an internal page not meant for wide distribution, a single line appeared and then vanished within hours. Pending review, interstellar object imaging, elevated clearance. Elevated clearance? For a comet? Why? There are only 2 categories of images NASA typically restricts: images containing national security sensitive hardware, images containing phenomena they cannot yet explain. And 3I Atlas is definitely not a spy satellite. So what does that leave us with? A top-tier camera pointed at an interstellar body for the first time in human history, and the results are suddenly elevated clearance. Loeb isn't the only one disturbed by that phrase. Several planetary scientists, anonymously of course, have expressed concern in private forums. Why is a comet being treated like a classified object? If there was nothing unusual, the images would be out already. This feels like 17 all over again, but bigger. That last comment refers to 2017, the year Oumuamua passed through our system, showed unexplained acceleration, and left scientists arguing for years. Many of those images were delayed too. Maybe that pattern is repeating. Or maybe this one is different, but Loeb senses something. And he's acting differently this time. Here's the detail nobody's talking about. Loeb has already contacted observing teams across Italy, Spain, and Australia. He's pushing for independent spectroscopy, independent trajectory fits, independent photometry. He's telling scientists, quietly, to stop waiting for NASA, because silence can be a mistake. Or silence can be a message, and in this case, silence is the loudest anomaly so far. Before we move on, ask yourself this. If the leading expert on interstellar objects is openly warning that the most important images are being held back, what exactly is in those frames? What did HiRise see that we still haven't? Whatever it is, Loeb's persistence has already caused something to crack. A leak is coming, not from him, but from someone who has access, and when it surfaces, we may understand why the agencies are moving so carefully. But first, we need to understand what happened the last time 3I Atlas was seen before the blackout, because the anomaly did not begin after perihelion. It began before. Before 3I Atlas slipped behind the sun and vanished for 72 hours, there was one image, one frame, that quietly circulated among small astronomy groups before being pulled down, replaced, and reposted with a different timestamp. If you weren't watching closely, you missed it. Most people did. But for the few who caught the original version, everything changed. It came from Hubble, taken on July 21st, long before the perihelion pass, long before the object transformed. At first glance, it looked ordinary, a dim nucleus, a pale dust cloud, a faint tail. But then someone noticed something wrong. The tail wasn't pointing away from the sun. It was pointing toward it, an anti-tail. Now, if you follow comet science, you might have heard explanations: geometry, projection effects, dust sheets aligned with the orbital plane. And yes, those things can happen. But here's the part that made professionals uneasy. Hubble wasn't viewing it from a strange angle that day. Its line of sight was only 10 degrees off the sun's direction, almost edge-on. That means what Hubble saw wasn't an illusion. It was a physical structure moving in the wrong direction, a jet, or something like a jet, throwing material toward the sun, not away from it. For a natural comet, that makes no sense. Not under solar pressure, not under radiation forces, not under standard sublimation physics. Particles don't fight the sun, they run from it. Yet this object didn't. When the image first appeared online, a few astronomers debated it in a small thread. They wondered if the dust was shaped by rotation, if the nucleus was elongated, if solar-wind interactions might create a temporary misalignment. But the thread vanished within hours, not deleted, replaced. Reposted with a corrected image where the tail looked softer, less distinct, harder to interpret. One amateur wrote a line that stuck with me. "I'm starting to think we're not correcting data, we're correcting the public." He didn't post again. And I need you to keep that detail in mind. The anomaly didn't begin after perihelion. It began months earlier, before the sun hid the object from view, before NASA withheld the HiRise images. The first hint was this anti-tail, this impossible structure reaching into the solar wind like a finger pointing the wrong way. But that wasn't the only anomaly in the July image. If you zoomed in carefully, and several people did before the image was replaced, you could see faint threads extending from the nucleus at odd angles, not the chaotic spray of natural outgassing, not the fractal branching of dust. These looked organized, thin, almost filament-like extensions that held their shape across multiple exposures. One amateur in Poland enhanced the image and circled 7 faint protrusions, not identical, but similar in size, spaced irregularly around the nucleus. He asked a simple question: do comets have vents arranged like this? No one answered him. Within hours, his post was locked. The image link went dead. To be clear, none of this proves anything. But it does show a pattern. Every time 3I Atlas shows something unexpected, the data becomes harder to find. Now here's where the story takes a turn most people still overlook. The July anomaly was not isolated. A second image was taken on August 5th, this one by an observatory in northern Italy. It briefly appeared on a minor astronomy board before being removed. The scientist who posted it claimed Hubble had captured another oddity: a small asymmetry in brightness, shaped like a curved spike, extending sunward. Not random, not diffuse, structured. He described it as a solar-facing plume that should not exist. Then he wrote a line that's been quoted quietly across scientific channels. If it looks like a controlled plume and behaves like a controlled plume, we at least need to ask what it is. Hours later, his account went inactive, and just like that, the trail went cold. Until October 2nd and 3rd, when the object passed Mars in high-rise captured the clearest photos ever taken of an interstellar visitor. And those images, the ones that could confirm whether these early anomalies were real or artifacts, are still missing. Ask yourself, if the July and August anomalies had innocent explanations, wouldn't high-rise be the perfect opportunity to prove it? But instead of clearing up the confusion, the highest resolution images vanished behind internal review. Not delayed for calibration, not queued behind other tasks, flagged, marked, locked, sidelined, which brings us back to the final hours before the object dipped behind the sun, the last image before the blackout. Taken on October 28th, only one day before perihelion, this one wasn't removed. It wasn't replaced. NASA posted it publicly, but with unusually low contrast. But someone obtained the raw FITS file, and when they adjusted the levels, something appeared. A faint blue-tinged glow around the nucleus. Not white, not yellow. Blue. Comets don't turn blue before perihelion. They redden with dust. They brighten with neutral gas. Blue is unusual. And blue before perihelion is almost unheard of. A researcher from France commented privately, either the composition is exotic or the heating was uneven. Uneven heating. Let that settle in. Something on the surface reacted differently under the sun's approach. Something stronger, something more structured, something that didn't sublimate the way normal cometary ice does. Whatever changed behind the sun, the first hints of it were already there, and they were visible long before the official story began. So the real question isn't what happened after the blackout. It's what 3I Atlas was preparing for as it approached it, and what it revealed about itself when nobody was supposed to notice. The days after perihelion should have been the loudest days of the entire 3I Atlas observation campaign. Objects from other star systems don't swing around our sun often. They don't survive the heat, the radiation, the tidal stresses. And when they do, agencies race to publish every frame. That's how it should have gone. But instead, the loudest moment in this story was absolute silence. The kind of silence that doesn't feel empty. It feels deliberate. Let's go back to the official explanation NASA gave when people began asking where the high-rise images were. The reasoning appeared on a single line on the high-rise website. Any images of the interstellar comet 3I Atlas are considered NASA-wide news. Due to the government shutdown, communications of NASA news have been suspended. Sounds reasonable at first glance, doesn't it? Except for one problem. The government shutdown ended days ago, and the images still haven't been released. Meanwhile, the same website continued publishing routine Mars images every single day. Dust patterns, crater scans, meteorite streaks. Business as usual. The cameras were working, the operators were working, the upload systems were working. Everything was functioning, except the one thing everyone was waiting for. Why single out these images? Think about that carefully. Not the object, not the science, not the complexity, just the images. Only the images were restricted. Not the telemetry, not the tracking, not the ephemeris updates, just the pictures. The clearest visual evidence of what the object looked like during the most extreme moment of its journey. And according to the notice, they require special approval. Special approval for a rock from another star system? That's when people like me, and people far more cautious than me, began to sense that this wasn't a simple procedural delay. Something didn't add up. Let's examine the logic. If the images showed nothing unusual, they would have been released instantly. They would have reassured scientists. They would have shut down speculation. They would have provided the baseline comparison needed after the object emerged. But the silence remained. Hour after hour, day after day. Even internally, people noticed the pattern. A planetary scientist from Arizona wrote, anonymously of course, NASA only takes this long when either the data contradicts the model or someone is debating how to explain what we're seeing. Another researcher from ESA said privately, if this were simply a comet brightening, the images would have been in the archive already. Someone is reviewing this very, very carefully. And here's the strangest detail. On November 9th, 4 days after the object reappeared, a placeholder page briefly appeared on a NASA server titled Interstellar object imaging, pending review. It was scrubbed within an hour. No mirror, no cached version, just a disappearance, almost as fast as some of the early amateur images that captured the anti-tail. This is where the silence becomes more than silence. It becomes a pattern. First, the Hubble anti-tail image in July was replaced. Then, the August brightness asymmetry vanished. Then, high-rise images were held. Then, NASA's placeholder page appeared, then disappeared. And after that, the public updates simply stopped. Even the usual small clarifying notes, the ones agencies use to reassure the scientific community, were missing. No timeline, no estimated release, no data under calibration, just nothing. Let me ask you something, and I want you to answer it honestly in your own mind. When was the last time you saw NASA and ESA this quiet about something this significant and involving an object this unusual at a moment this critical? I'll tell you the answer. Never. The silence doesn't match the event. It doesn't match the urgency. It doesn't match the scientific opportunity. The only thing it matches is discomfort. As if someone somewhere is trying to decide, do we show the world what this object looks like now? Or do we wait until we understand it ourselves? And that's not the kind of silence you get from bureaucracy. That's the kind you get when a story inside the building isn't aligning with the story outside it. Because here's the truth most people still overlook. The perihelion passage wasn't the anomaly. It was the result of the anomaly. Something changed on the way in. Something intensified behind the sun. And the agencies are not acting like everything is fine. Before we move forward, let me leave you with one detail. A detail that bothered me more than anything else so far. A scientist who has worked with HiRISE for years told someone off the record, "We release Mars images instantly. But the 3i Atlas images, those went straight to a different server." A different server. That single sentence says more than any official statement ever will. Which brings us to the next question, the one no one wants to ask publicly. What was in those images that made someone move them out of the normal pipeline? Before the silence took hold, before the images vanished behind special approval, there was one piece of information scientists couldn't hide because it was already baked into the orbital math. The trajectory of 3i Atlas didn't match the model. At first, it was subtle, barely noticeable. A deviation so small, most astronomers dismissed it as noise in the early observations. But as more data came in, the noise didn't fade. It sharpened. On October 31st, just 2 days after perihelion and 1 day before the blackout, multiple independent teams reported the same conclusion. The object was experiencing non-gravitational acceleration. Now, to be fair, comets do this. Outgassing, the rocket-like effect when ice sublimates, can push a comet slightly off its predicted path. It's well documented. It's normal. But what wasn't normal was the timing, and the direction, and the strength. The acceleration didn't match any known sublimation curve. It didn't match the expected thermal response. It didn't match the dust output measured earlier. It was wrong. One astronomer described it carefully, almost too carefully. Something is pushing the object in a way that's difficult to reconcile with standard models. That's the polite version. The truth? The numbers didn't behave like a natural comet. Let me explain without the jargon. When a comet approaches the sun, its outgassing increases gradually, peaks near perihelion, then fades. The acceleration caused by these jets follows a predictable pattern. But 3i Atlas didn't follow that pattern. Its acceleration spike came before the expected heating peak. Then flattened, then spiked again. Almost like corrective bursts, small, measured, directional. But even that isn't the strangest part. When researchers looked at the orientation of the jets visible in amateur time lapses, the ones pointed toward the sun, not away from it, something became clear. The directions of the visible jets did not correspond with the direction of the unexpected acceleration. That is not what natural outgassing does. If a comet releases material in one direction, the push goes the other way. Simple physics. But with 3i Atlas, the math didn't line up with the images. One team in Spain wrote quietly in a private group, "We are observing vectors that do not match the source of propulsion." Source of propulsion. That should tell you exactly how unsettled they were, because that word is propulsion is not used lightly. But here's the twist. Nobody goes public with this kind of anomaly unless they can point to the missing images and say, "This is why." And NASA's silence removed that safety net entirely. Without the high-rise photographs, scientists are left with math, diagrams, and blurry ground-based images that show a structure more stable than expected. And something else. The object did not fragment after perihelion. Not even partially. No secondary bodies, no trailing debris. Nothing. Instead of falling apart, it became more defined. The tail lengthened, the jets sharpened, the halo expanded, and I need you to think carefully about what that means. Heat destroys fragile structures. Radiation disrupts weak nuclei. Comets break, crack, shed mass. But this object did the opposite. Let me put it plainly. Whatever changed behind the sun, it made 3I Atlas stronger, not weaker. One researcher from Portugal noted, "It is maintaining stability under thermal stress that would devastate a loosely bound body." Maintaining stability under perihelion level radiation. That is not the behavior of an icy rock drifting through space for 1,000,000 years. That is the behavior of something built to endure. But let's stay grounded, because the truth does not require exaggeration. We don't know what caused the acceleration. We don't know why the jets point in the wrong directions. We don't know how the object held together. What we do know is this: the data does not match any natural model we have. And the one set of images that could confirm or deny these anomalies is the only data set NASA hasn't released. Ask yourself, if the acceleration was normal, why hide the images? If the jets behaved as expected, why lock the files? If the object was just another interstellar comet, why does the math say otherwise? These are not claims. These are questions. Questions no one inside the major agencies seems willing to answer. And this leads us to an even more unsettling thought, one that astronomers have whispered privately but never publicly. What if the anomalous acceleration wasn't random, but intentional? Not propulsion, not engines, not technology, but something more subtle, a maneuver, a course adjustment, a correction. And if that possibility makes you uncomfortable, good, because the next piece of evidence will make you question even more. The jets didn't just push the object, they were arranged. 3 of them formed a geometric alignment that no natural comet has ever displayed. And the moment that alignment was first noticed, it marked the point where the official updates began to slow. Before the world argued about radio signals, before the images were flagged, before scientists began whispering words they normally avoid, there was one clue so strange, so undeniably out of place, that several observatories quietly removed their own commentary rather than try to explain it. The geometry. Not the tail. Not the brightness. Not the halo. The arrangement. For a natural comet, jets appear in messy, chaotic bursts. They flare, fade, shift with rotation, crumble as vents collapse. Nature does not arrange outgassing into patterns, but 3I Atlas did. The first hint arrived on November 9th when a trio of astronomers, Jurger, Rayman, Prosperi, published an image they thought would be routine, a simple post-perihelion capture. Instead, it stopped the scientific community cold. 7 distinct jets, not diffuse, not smeared, not random. 7, each separated, each holding its own direction, each too stable for a nucleus that had just endured perihelion-level heating. But that wasn't the anomaly that unsettled people. The anomaly was the spacing. 3 of the jets formed a perfect arc, a curve so precise that when overlaid with a simple geometric model, the deviation from symmetry was less than 3%. No comet does that. Dust vents don't respect geometry. Ice pockets don't space themselves evenly. Fragments don't coordinate. Yet the image showed an unmistakable pattern. One researcher wrote privately, "This looks like a structured release, not a chaotic one." He deleted the comment minutes later. But by then the image had already been downloaded, analyzed, overlaid, studied. People began drawing lines, measuring angles, comparing the distribution to known comet behaviors. It didn't match anything in the record, not Hale-Bopp, not 67P, not Borisov, not even the exotic outgassing from Oumuamua. This was cleaner, sharper, more deliberate. Let's stay grounded in the data, because the truth is powerful enough without embellishment. The jets had three troubling characteristics: directional consistency. Several pointed toward the sun, a violation of basic comet physics. Comet jets get pushed away, not pulled in. Coherence over distance. Some jets extended hundreds of thousands of kilometers without diffusing. That level of collimation suggests a confined source, not a porous one. Geometric spacing. Three jets in particular formed a repeating angle, approximately 42 degrees apart. Not perfect, but close enough to trigger concern. One ESA scientist wrote in a restricted chat, "If these are vents, they are arranged. If they are arranged, something shaped them." Minutes later, he clarified, or tried to, "I'm not implying anything, just noting the anomaly." But everyone had already seen the first version, and here's where the silence deepens. After this image circulated, ESA issued no follow-up commentary. No clarification, no correction, nothing. The next day, another image appeared, this time from Nebling and Barner. Two large anti-solar jets, one massive main tail, and again, that same faint geometric structure lurking beneath the brightness. The shape was clearer this time, a subtle curved symmetry around the nucleus. Not artificial, not mechanical, just unnatural. And this leads to a question most people are afraid to ask. Why is a comet from another star system showing a level of structural organization that no comet formed around our sun has ever displayed? Let me be clear. This is not proof of technology. This is not evidence of intention. This is not a claim of design. This is a pattern. And in science, patterns demand attention. But the timing of the geometry raises an even more unsettling point. The jets didn't display this arrangement before perihelion. The structure appeared after the blackout, so whatever happened behind the sun, whatever changed the object's color, brightness, acceleration, also changed its shape. A comet doesn't rearrange itself after surviving the most violent part of its orbit. It fractures, it weakens, it falls apart. But 3I Atlas did something no natural body should do. It organized. And here's where the mystery sharpens even further. When the angles of the jets were plotted against the trajectory shift measured on October 31st, something uncanny emerged. The acceleration vector, the direction of the unexpected push, aligned almost exactly with the geometric arc, not perfectly, but close enough that several astronomers privately wondered whether the geometry and the acceleration were linked. One wrote, "It's almost as if the jets respond to a control axis." He deleted the message 5 minutes later. What does that mean? Nothing conclusive. But everything's suspicious, because if the jets contribute to the acceleration, and if the geometry is real, then we're no longer looking at random outgassing. We're looking at something that behaves like a system, not a machine, not a probe, just not a rock. And this brings us to the most haunting question so far. If the geometry didn't exist before the blackout and appeared only after the object emerged, what happened behind the sun? What changed? What reorganized? What strengthened instead of breaking? The agencies aren't answering. The images are still withheld. And the only data we have is from the telescopes they don't control, which means the next anomaly, the one that pushed this story into even stranger territory, came from the only source that cannot be censored, the sky itself. When 3I Atlas emerged from behind the sun, astronomers expected the same thing they expect from every comet after a scorching perihelion pass: fading, weakening. A slow unraveling as the nucleus sheds mass and the dust cloud collapses back into darkness. But 3I Atlas did the opposite. It grew. The first post-perihelion images taken by ground-based observatories showed a halo expanding far beyond its pre-perihelion size. Not by a few thousand kilometers, not by a marginal increase, but by hundreds of thousands of kilometers, 500,000 kilometers. Let that number settle in, a halo the size of the distance between Earth and the Moon. For a moment, astronomers assumed their sensors were saturated. Maybe the exposure times were off. Maybe the filters were misaligned, but then another team captured the same thing, and another, and another. It wasn't an error. It was real. The halo was not dissipating, it was building. Now, halo expansion isn't unheard of. Comets release dust, gas, and ions after perihelion. Heat penetrates deeper layers. Material escapes. But not like this. Not in a way that creates a smooth, symmetric envelope. Not in a way that maintains its shape over days. Not in a way that suggests the entire structure is being fed by a stable, sustained process. One astronomer from Italy phrased it delicately. The coma is remarkably coherent. It is not behaving like a debris cloud. Remarkably coherent. Natural comets break down into chaotic filaments, ragged sheets of dust, uneven expansions. Their halos ripple and distort as they interact with the solar wind. But 3I Atlas showed a glow that held itself together, thickening like fog illuminated from within. Here's what made it even stranger. The halo expanded faster than the calculated sublimation rate could justify. Not double, not triple, several times faster. And it did so in pulses. Every 4 to 5 hours, the brightness curve rose, sharply, abruptly, then stabilized. A regular rhythm. A pattern. Comets don't pulse, unless something inside them is releasing material in cycles, not chaos. And then came the detail that unsettled everyone who saw the early data. The halo was not brightest at the center. It was brighter in a ring just outside the nucleus, a faint torus of light, visible only after heavy contrast adjustments. A ring, not a blob, not a diffuse smear. A circular band. One researcher described it privately. It looks like a pressure wave, not a dust cloud. Pressure wave. Think about what that implies. Not a blast, not fragmentation, but a steady outward force, something pushing material outwards in a controlled, consistent manner. And if that's true, the big question becomes, what is generating the pressure? Natural jets? Possibly. Deep subsurface heating? Maybe, but the ring structure suggests something far more organized, like vapor escaping through multiple vents at coordinated intervals, maintaining symmetry as the halo expands. When the French team ran a simulation of dust motion based on observed velocities, they expected asymmetry. That's what you get from fragmented or unevenly heated comet nuclei. Instead, the model that matched the data best was one where the vents were evenly spaced, not perfect, not mechanical, but too structured to ignore. And then came the subtle detail that tied everything together. The expanding halo aligned with the same axis as the geometric jets from Chapter 6, almost perfectly. 3 independent teams noticed it. Not publicly, no one dared risk speculation in print, but in private discussion channels, the same thought kept surfacing. Why is every major anomaly lining up along one axis? The anti-tail, the geometric jets, the acceleration vector, the halo ring. Different data sets. Different days, different instruments. One axis, as if the object has a preferred direction, as if something inside it operates along that direction, as if the entire structure is oriented around that unseen line. This is where the story turns from unusual to unsettling. Because in natural celestial mechanics, there is no reason for all these features to align unless the nucleus is rotating in a very particular way, with a stable axis that survived perihelion intact. But survival wasn't expected. Stability wasn't expected. Coherence wasn't expected, yet here we are. Before we move on, consider this. If the halo grew in pulses, and if the jets were geometrically spaced, and if the trajectory changed at the same time, then 3I Atlas isn't just reacting to the sun, it's responding to heat, to internal stress, to something we haven't identified. That question, the one scientists are afraid to voice publicly, is what led to the next moment in this investigation, when the object produced a signal no one expected. 5 days before perihelion, when every telescope on Earth was pointed at 3I Atlas in visible light, something else was listening. Not for brightness, not for jets, not for geometry, for sound. Not literal sound, but the radio whisper of molecules being torn apart by the sun's heat. The kind of whisper that only the most sensitive arrays can hear. And on October 24, 2025, the Meerkat radio telescope in South Africa heard something it did not expect. A signal at 1.666 GHz, the waterhole band, the quietest natural window in the entire electromagnetic spectrum. A place where hydrogen and hydroxyl molecules speak, and where for decades SETI researchers have argued that any intelligent species would transmit if it wanted to be heard. But this wasn't a beacon. This wasn't a message. This wasn't language. At least, that's what the scientists said publicly. Privately, some weren't so sure. Let's start with the basics, the explanation agencies rushed to provide. Hydroxyl radicals, OH molecules, the byproduct of water ice breaking apart under extreme solar radiation. Many comets show OH lines near this frequency, and that explanation is true. It fits the chemistry. It fits the physics. But it doesn't fit the timing, because 3I Atlas had been heating for weeks. The sublimation curve didn't suddenly peak on October 24th. Its dust and gas production didn't suddenly surge. So why did the OH signature appear only once, sharply and clearly, and then vanish? Not fade. Not taper. Vanish. Natural outgassing doesn't behave like that. It rises. It falls. It breathes with the rotation of the nucleus, but the Meerkat detection was a spike, a clean, narrow event. Sharp onset. Sharp fall-off. No follow-up, a pulse. One astronomer described it quietly. It looked like a single exhalation. Another added, I have never seen a comet give a signature that clean, but the part that unsettled people wasn't the clarity, it was the focus. The absorption lines were centrally concentrated, coming from a very tight region near the nucleus, not a diffuse cloud, not a broad coma, not an expanding sheet of gas, a point. Here's why that matters. If the OH emission were natural, it should spread. Diffuse, scatter, spread across millions of kilometers. But the dataset Meerkat published, the only one they shared before going quiet, showed a compact source. In other words, something at the heart of 3I Atlas emitted O in a way that looks less like random outgassing and more like a controlled vent. Again, this doesn't prove intention, but it does prove that something at the core behaved differently than expected. Now here's the detail almost no one has discussed publicly. The 1.66 GHz band is not just the hydroxyl line. It is the exact harmonic spacing above 1.42 GHz, the hydrogen line. Hydrogen plus hydroxyl H plus OH, the two fundamental ingredients of water, and the region between them? Nicknamed by SETI pioneers as the water hole, the place where a technologically advanced species might broadcast, because hydrogen and hydroxyl mark the chemistry of life itself. Nobody is saying this was a broadcast, but the coincidence is enough to make people uncomfortable. But the deeper anomaly was still ahead. A technician from Meerkat, someone whose job is merely to calibrate raw data, noticed something that didn't make the press release. A microshift. A Doppler offset in the OH line that suggested the gas wasn't drifting away at normal comet speeds. Not 300-600 meters per second. Not the usual sublimation drift. It was faster, not by much, but noticeably. Enough to push it into an unusual category. He wrote in a log note before it disappeared from the online system. Velocity inconsistent with passive OH dissociation. Passive, not active, a single word that says everything without saying anything. And this raises a question most scientists are too careful to ask aloud. If the OH pulse didn't fit natural sublimation, what triggered it? Heat? Stress? Rotation? A crack? Or was it something like a vent opening suddenly, a brief release of pressure, then closing again? Because the signal did not repeat. Not on October 25th, not on October 26th, not during perihelion, not after. One pulse, one moment, one event, and then silence. Now imagine this. 5 days later, the object entered the solar blackout. 72 hours in a space no telescope could see. And when it re-emerged, its jets were structured. Its halo was enormous. Its brightness had shifted into the blue. and the geometry around the nucleus was entirely new. So here's the question nobody can answer. Was the OH pulse a natural spike, or the first sign of a deeper change? Because nothing about 3I Atlas before the blackout fits what it looked like after. And if something happened near perihelion, some internal transformation or structural shift, then the OH burst may have been the first clue. The agencies won't say it. They won't even comment on it. But several researchers now believe the timing isn't a coincidence. The pulse came 5 days before the sun took the object from our eyes. 5 days before the transformation. 5 days before the silence. When 3I Atlas slipped behind the sun, astronomers braced for a familiar kind of uncertainty, the kind that happens every time an object enters solar conjunction. But this time, the uncertainty felt different, not because the disappearance was unexpected, but because of what happened before it vanished and what didn't happen during the blackout. Let's start with something simple. Every comet that passes behind the sun produces at least a faint signature. Scattered light, radio noise, a whisper of ionized debris bouncing off the solar wind. But 3I Atlas did not. On October 29th at 0312 GMT, the object crossed into the zone no instrument on Earth could see directly. That wasn't the anomaly. That part was normal. The anomaly was the silence. Total silence. For 72 hours. Not a flicker, not a spike. Not a trace of scattered dust. Nothing. Not even the faint hum of ionized particles you'd expect from a small debris plume. As far as our instruments could tell, the object didn't just go behind the sun. It disappeared. But before we get to that, let's rewind 2 days, October 27th and 28th, the final pre-perihelion window. Every telescope caught the same thing. Brightness rising faster than the thermal models predicted, angel-haired jets extending in directions no comet should point, a developing halo that felt more like a shell. Scientists told themselves they'd get answers after perihelion, after it emerged, after they could see the nucleus again. But when the object entered the blackout zone, the data feed didn't dim. It flatlined. And here's where the story bends toward the unnerving. During solar conjunction, at least one spacecraft usually glimpses something. SOHO, Stereo A, ACE, even the coronagraphs positioned at Lagrange points, they all catch partial signatures. Blurred, distorted, weak, but not zero. Yet 3I Atlas produced exactly zero. One researcher at Goddard noted in a private chat, "This isn't low signal, this is no signal." Another added, "Even fragments leave streaks behind the corona. Where is this thing?" It wasn't a question born from panic, it was a question born from confusion, because the sun doesn't hide objects perfectly. Its corona lights everything on fire. Debris glows, gas glows, dust glows, and even when a comet is fully occluded, the solar wind warps its particle stream, creating faint tracer signatures in radio frequencies. But for 72 hours, 3I Atlas behaved like a whole. A void, a missing page, a blackout with edges too sharp. Now, let's consider the possibility scientists didn't want to voice. What if the disappearance wasn't just geometry? What if something happened to the object itself during the blackout window? This is where the OH pulse from Chapter 8 re-enters the picture. A single concentrated burst, a pressure signature. Then silence. 5 days later, the object enters the sun's shadow, remains invisible longer than expected, and emerges transformed. Brightness altered, color shifted, jets reorganized, halo expanded. Something happened behind the sun, something that left no trace until the object stepped back into view. But the most troubling detail is this. The blackout lasted longer than the models predicted. Astronomers expected 3I Atlas to re-emerge after 66 hours. It took 72, 6 hours, 6 hours of missing trajectory, 6 hours where the predicted position and the observed position didn't align perfectly. Not a huge change, not enough to call it controlled, but enough to call it strange. And here's the strange part. Objects don't slow down behind the sun. They accelerate. A gravitational slingshot around a star always increases speed. Always. But 3I Atlas came out slower than expected, slightly, subtly, but measurably. A deceleration. One scientist tried to explain it to a colleague. Imagine throwing a knife. Now imagine it comes out the other side of your target moving slower, but still intact. Intact. That's the word that keeps coming back. The nucleus should have fractured. The outer layer should have boiled off. The jets should have shifted randomly. Instead, the object emerged, organized, and brighter. But here's what sealed the unease inside the scientific community. For 3 days, NASA and ESA made no comment. No data pending. No analysis ongoing. Not even a standard solar conjunction complete. Nothing. The silence from space had a matching silence on Earth, the kind of silence you get when people know what they saw, but aren't sure how to explain it. Before we move to what 3I Atlas looked like the moment it reappeared, let me leave you with one last thought. Objects don't vanish behind the sun. Not like this. Not without a trace. Not without a whisper, unless something kept it from leaving one. When 3I Atlas finally stepped out from behind the sun, astronomers expected a familiar reunion, a dim, red object, exhausted from heat, trailing the usual debris a comet leaves behind after a close solar pass. But that isn't what happened. The first image that surfaced didn't come from NASA or ESA or any major observatory. It came from a small amateur telescope in northern Chile, a faint, shaky frame, barely stabilized, posted without explanation. And yet that blurred image said something no agency had said aloud. 3I Atlas was back. But it was not the same object that disappeared. The nucleus was brighter than it should have been, unnaturally so. Not the warm, dusty glow of a heated comet, but a colder, sharper light. A color shift no one expected. Before, perihelion, it had been red, dusty, muted. But the object that emerged carried a blue tint, faint but undeniable. A change that should not happen in only 72 hours, especially not under the most violent conditions any small body can endure. One astronomer described the first frame carefully. This is not the brightness curve we predicted. Another wrote, the coma should be collapsing. It appears to be expanding. But the part that tightened every throat in the observation room wasn't the color or the brightness or even the shape. It was the silence. NASA did not acknowledge the first amateur image. ESA did not reference it. The major observatories, the ones that had been posting daily updates, paused as if waiting for someone to tell them what to say. No welcome back message. No standard object reacquired. Not even a technical note, just quiet. And in that quiet, more images began to appear. Some from backyard telescopes, some from university observatories, some from corners of the internet that normally never look at the sky, each image different, each image imperfect. But they all confirmed the same unsettling truth. The object that emerged from behind the sun was brighter, bluer, and more intact than any natural model predicted. Comets survive perihelion by luck, usually by losing mass, almost always by shedding large pieces of their structure. But 3I Atlas looked untouched, not fractured, not weakened, not distorted, intact. And for astronomers who have spent years studying comets, that was the most disturbing part. Because if an object enters perihelion fragile, it should exit in pieces. If it enters dusty, it should exit red. If it enters faint, it should not reappear brighter than before. Yet here it was, a visitor from another star system, returning from the sun not battered, but renewed. Different, changed. One observer wrote, "It looks as though it went behind the sun as one thing and came out as something else." And that sentence, whispered quietly in a late-night data review, captured exactly what the scientific community felt but wouldn't say publicly. We were no longer observing the object we thought we understood. We were witnessing something that didn't fit the models, something that didn't match the predictions, something that shouldn't have survived but did. And the moment it returned, everything about the story changed. The first warning didn't arrive in the form of a dramatic image or a leaked document. It arrived as a hesitation, a pause so brief that only people who watch the sky for a living would notice. When 3I Atlas reappeared, every major observatory ran its standard reacquisition protocol. Point, track, confirm. It should have taken minutes. Instead, it took nearly an hour, and no one wanted to say why. The earliest telemetry looked normal on the surface. Right ascension, declination, brightness. Nothing screamed danger, but underneath those numbers was something that made astronomers tighten their jaws. Nothing lined up perfectly. Not the coordinates, not the brightness curve, not even the coma structure. Imagine looking at someone you've known for years, same face, same voice, but something in their eyes is unfamiliar. That was 3I Atlas. One researcher at Cerro Tololo later admitted, "We all saw it. Nobody wanted to be the first to put it in words." Mini-hook aside, the data spoke louder than any confession. The first anomaly came from the timing itself. Atlas emerged earlier than predicted, not by much, but enough to matter. These objects don't improvise. A visitor from interstellar space should obey the cold precision of celestial mechanics. Yet, here it was, slipping out of the sun's glare as if it had chosen the moment. The second anomaly was subtler, a problem embedded in the brightness shift. Post-perihelion objects dim, cool, stabilize, but Atlas didn't fade. It flared, a smooth rise, steady, unnatural, a glow that looked less like reflected sunlight and more like a signature. Then came the micro-reveal, the detail that pushed everyone from discomfort into unease. Its coma wasn't expanding normally. Instead of dispersing into a messy halo, the material seemed to hold shape, forming a faint, ring-like structure that tightened rather than loosened. One scientist whispered, "I've never seen dust behave like it has boundaries." Boundaries. A forbidden word in comet science. Dust doesn't obey invisible borders. Gas doesn't arrange itself into patterns. Natural objects don't create geometry. But the coma around 3I Atlas was doing exactly that, forming a thin, coherent band, almost like a ripple frozen in place. And then came the part no one wanted to address publicly. The early images, the blurry amateur ones everybody mocks, showed the ring more clearly than the high-budget observatories. Amateurs shouldn't outperform agencies. They shouldn't be the first source of structure. They shouldn't be the only unfiltered window we have. Yet they were. And the agency stayed silent. No correction, no clarification, not even a dismissive instrumental artifacts. Just quiet. A researcher from an ESA affiliate sent an anonymous message to a colleague. "It's not the shape we expected, and that's why no one wants to talk." Touchline, if the people who know the most are the ones speaking the least, what exactly did they see? As astronomers attempted to reconcile the new data, one more inconsistency appeared. Small, but devastating. The object's post-perihelion drift didn't match the pre-perihelion trend. That alone isn't impossible. But the direction of deviation was backward, a correction against the expected force vectors, not chaotic, not random, precise, like something compensating. The data analysts debated it behind closed doors. Some called it an observational glitch. Others, a model failure. No one used the word controlled, but everyone thought it. And as the numbers settled into place, that one thing became clear. This wasn't just a new chapter of the same story. This was the beginning of a different story entirely, one where the object wasn't merely surviving the sun, it was responding to it. The numbers arrived quietly, almost timidly, as if they were ashamed of what they represented. Data packets from observatories across 3 continents began syncing within the same hour. Brightness logs, spectroscopic readings, positional updates, coma density estimates. On any ordinary day, these numbers would align into something calm and predictable. But that day, they refused to sit still. The first inconsistency appeared in the raw photometric series. Every instrument, big or small, old or modern, recorded a spike that made no sense. A brightening event lasting nearly 8 minutes. Too long to be an instrumental glitch. Too short to be any known natural outburst. A Harvard researcher tried to rationalize it. Maybe it shed a surface layer. But the thermal models disagreed. The heat signature implied no such mass loss. In fact, and this was the part nobody wanted to say out loud, the thermal profile suggested a stabilization, not a fragmentation. Objects don't stabilize after perihelion. They cool unevenly. They release heat in bursts. They crumble. 3I Atlas was smoothing out. The second anomaly was buried in the spectroscopic data. Different observatories sampled different wavelengths, but all reported the same thing. The signature wasn't matching any common outgassing model. Where there should have been chaotic spikes, there were gentle rhythmic pulses, almost like a breathing pattern. Too periodic to ignore, too faint to explain. One analyst wrote privately in their notes, "It's as if the emissions repeat on a cycle that is uncomfortable." The third anomaly came from the positional drift. The farther the object traveled from the sun, the more its path diverged from the gravitational prediction. Not dramatically, not recklessly, just enough that every data analyst felt a tightness in their chest. Something was nudging it, something subtle, something consistent. Natural objects do not correct themselves. But this one kept returning to a path no one had programmed, and that was only the beginning. The micro-reveal arrived from the least expected place, an observatory in New Zealand that almost didn't submit its logs because of possible sensor contamination. Their images showed a faint radial structure extending from the object. Not random, not chaotic, aligned. 3 spokes of brightness, thin, sharp, arranged like the faint outline of a wheel blurred by motion. No one else had captured it. Not because it wasn't there, but because most telescopes were pointed at slightly different angles. The New Zealand team's vantage point was unique. They published nothing. They only left a single line in the internal report. "We are not confident in interpreting this structure, but the pattern was unmistakable. Dust doesn't organize itself. Gas doesn't form spokes, and nothing faint enough to be a comet should create radial symmetry." Touchline: when numbers begin whispering the same story from different corners of the world, you should ask yourself why the people in charge are afraid to read it aloud. Meanwhile, NASA and ESA remained publicly silent. No clarifying statement, no reassurance. Not even a generic, "We are analyzing the data." Amateur astronomers filled the void with their own analysis, and some of their findings were even more disturbing. One observer plotted brightness fluctuations and discovered a tiny pattern repeating every 22 minutes. He dismissed it as coincidence. Another compared color indices hour by hour and found a slow, steady shift, moving toward the blue end of the spectrum by microns. She hesitated before posting her graph, and the longer this went on, the more undeniable it became. The numbers were not just strange. They were afraid of being explained. By midnight, a document circulated privately among several universities. It contained a simple sentence no one wanted attached to their name. "The object's behavior is inconsistent with natural models." No elaborate theory, no sensational claim. Just that one sentence, enough to change the tone of every meeting that followed. Because once the numbers betray the models, the question isn't what is this object? It becomes, what has been hiding behind the data this entire time? It surfaced at 2:14 a.m. UTC. No watermark, no credit, no accompanying text, just a single frame uploaded to an obscure astronomy forum known mostly for blurry moonshots and debates about telescope filters. At first, no one paid attention. It was low resolution, soft, almost dismissible. But then someone zoomed in, and everything changed. The image showed 3I Atlas, but not the soft, diffuse glow everyone expected. Not the grainy halo of a natural object struggling after perihelion. This was different, sharper, cleaner, defined in a way that should be impossible for a body millions of kilometers away. At the center of the frame was a shape, faint, almost dissolved by noise, but too structured to ignore. It wasn't round. It wasn't irregular. It wasn't comet-like. It was segmented, 3 faint arcs positioned around a central point, like ribs of a collapsed sphere or the remains of a broken shell. No telescope should capture that much structural clarity. Not at this distance, not at this angle, not with that small of an aperture. The forum users argued immediately. Artifact from sharpening, stacking error, sensor ripple. One insisted it was just heat bloom, but then a second image appeared. Different user, different country, different type of telescope. Same structure. This time the arcs were clearer, and the central point was brighter, almost like a node emitting a thin stream of light. A jet, a fracture, a reflection? Except the geometry was too consistent. A veteran deep sky observer commented, "Nature doesn't repeat lines like this, not at random." Within 20 minutes, the thread vanished, deleted entirely. Every post, every attachment, users who tried to reload the page were met with a maintenance message. The site had been stable for 12 years. It hadn't gone down once. That was the first silence. The second silence came when several users attempted to re-upload the images to other forums. 5 attempts, 5 immediate deletions. No explanation, no system messages, just removal. And then, the most unsettling part. One of the observers received an automated email from his cloud storage stating that an image in your account has been flagged for abnormal metadata. He swore he had not modified the file. Metadata? Abnormal how? The email did not say. And that's when the whispers began. Why delete a frame if it shows nothing? Hours later, someone leaked a stabilized version, a stack of 30 images aligned and boosted in exposure. And the structure was no longer vague. It was real. A faint skeletal pattern extending outward from the nucleus. Not dust, not gas, not noise. 3 arcs, evenly spaced, converging toward a central core. A symmetry no natural coma should possess. And that was only the beginning of the anomaly. The brightness at the core wasn't consistent with reflected sunlight. Its fall-off curve didn't match known scattering profiles. Instead, it tapered with mechanical smoothness, as if it were a controlled gradient, not a chaotic plume. One physicist who viewed the leak wrote privately, "This is not sublimation, it looks engineered." He deleted the message minutes later. Touchline: if an image that shouldn't exist somehow does, you have to ask who tried to keep it from you, and why they failed. By dawn, the stabilized frame had spread quietly among researchers. Some dismissed it, some feared it, most ignored it publicly, but deep inside the late-night channels where scientists talk without titles or institutions, a question surfaced again and again. If this is not a natural structure, then what are we actually looking at? The morning after the leaked image circulated, something even stranger happened. Not in the sky, but on the servers. Astronomers woke up expecting the usual: calibrated brightness logs, updated orbital solutions, routine positional datasets. Instead, the newest data drop felt wrong. The numbers didn't match the sky. At first, it showed up as a tiny mismatch in magnitude readings. Several observatories reported 3I Atlas dimming by 0.08 magnitudes overnight, a perfectly normal fluctuation for an object shedding volatile material. But amateur astronomers in Australia reported the opposite. Their tracking logs showed a subtle brightening. 2 sets of observers, 2 hemispheres, 2 opposite trends, both equally confident. One observatory dismissed the discrepancy as software misalignment. Another suggested a calibration error. But then the European data came in, and it agreed with the amateurs. The object was brightening. The official data was not. That was anomaly number 1. Anomaly number 2 emerged from a different corner, the orbital solutions. Every calculation provided by JPL's public database showed the same thing, a smooth, predictable deceleration as the object moved farther from the sun. Except telescopes tracking the actual sky measured something else. 3I Atlas was drifting. Not much. Not dangerously, but drifting consistently by a fraction of a millionth second every hour. Too small for the public to notice. Too persistent for professionals to ignore. One researcher wrote in a private Slack channel, "If this data is correct, the object is compensating for solar wind pressure instead of being pushed by it. That should be impossible." The message was deleted within minutes. The third inconsistency came from the coma density models. The software predicted the outer halo should begin to collapse as the object cooled. But the sky said the opposite. The coma wasn't collapsing, it was reorganizing, forming filaments. Shifting clumps of brightness that traveled faster than dust should travel. It almost looked self-sorting, a behavior no natural comet has ever shown. Not even in extreme cases like ISON or Enki. When someone pointed this out during a virtual coordination call, the moderator ended the meeting prematurely with the phrase, "We need to wait for official confirmation." But confirmation never came. Meanwhile, a graduate student in Chile noticed something disturbing. He overlaid ESA's official position data with the amateur-tracked coordinates from 3 separate nights. They didn't align, not even close. It wasn't a rounding issue. It wasn't a timestamp error. It wasn't poor tracking technique. No matter how he corrected the data, the official numbers lagged behind the real sky, always by nearly the same offset. It was as if the object we were being told to track was not the object actually in the sky, or worse, as if the official data was deliberately dampened to hide the drift. Touchline: when the sky says one thing and the files say another, trust the sky. The final crack in the narrative came from a curious discovery in an archival server. A researcher trying to reconcile coma models accidentally accessed a cached dataset, one timestamped a full 6 hours before the official release. That older dataset matched the amateur data perfectly, but the public-facing version had been corrected to align with the expected model. Not with the reality above our heads. The researchers shared this finding with 2 colleagues. The next morning, the cached dataset had vanished, overwritten by a blank placeholder. And that was the moment the question shifted. No longer, what is 3I Atlas? Now it was, why is someone trying to make it look normal? Because numbers can be wrong. Instruments can malfunction. Analysts can make mistakes. But when the sky says one thing and the numbers insist on something else, someone is rewriting the story. It began the way most breakthroughs do these days. Not in a multi-million-dollar lab, not inside a government observatory, but in a dimly lit backyard where a single amateur refused to look away. His name wasn't released publicly. The astronomy forums knew him only by his handle, Deep Field Ghost. He wasn't a professional. He didn't have grants or institutional backing. His telescope was a 6-inch reflector older than he was, but what he had, what none of the official channels seemed to have, was time. And an obsession. While major telescopes were scheduling short exposure windows around daily priorities, he was taking back-to-back frames for 6 straight hours. He stacked the exposures carefully, aligned every pixel, corrected for seeing, cleaned every trace of noise. And at 3:11 a.m. local time, something appeared on his screen that should not have been there. Not a flare, not a dust plume, not a sensor glitch, a pattern, a faint repeating structure pulsing inside the coma. Too regular to be dust, too symmetrical to be noise, and too persistent to be an artifact. A wave, not light, not shadow. Something in between, a rhythmic modulation that repeated every 26 minutes, almost like a heartbeat. At first he thought it was equipment interference, so he switched cables, switched software, even switched power sources. The pattern remained. He uploaded the raw frames to a small Discord server for amateur astronomers. Only a handful were online. One of them, a PhD student from South Korea, ran a Fourier transform on the brightness variations. The results nearly froze the entire room. The wave wasn't random. It followed a predictable curve, a decaying sine pattern superimposed onto the brightness of the nucleus. Natural objects do not oscillate with mathematical precision. Comets breathe in chaos, uneven, violent, unpredictable. Atlas was breathing to a rhythm. Within an hour, more amateurs replicated the finding. Different countries, different cameras, different skies, same pulse. One observer in Italy described it. It's as if something inside the object is rebalancing itself, like a system running a calibration loop. That statement should have gone viral. But minutes later, his post disappeared. So did the screenshots. So did his account. On the Discord server, someone posted a chilling message. Be careful, they're watching the tags. And then the real shock hit. A university researcher, anonymously, sent a direct message to the group. We detected the same periodicity 2 nights ago. We were told to classify it as noise. Noise, the most convenient label in science, the place where anomalies go to die. But the amateurs didn't accept that. They kept digging. One of them cross-referenced the pulse timing with the brightness data collected on the opposite side of the planet. Perfect synchronization. If this were noise, it would be random. If this were thermal flickering, it would vary with angle. If this were dust scattering, it would change with exposure length. But it didn't. The pulse was global. Across continents, across instruments, across observers who didn't know each other. Touchline. When amateurs with mismatched telescopes detect the same rhythm, that rhythm isn't noise. It's a signal, not a communication signal, not a message, but a behavior. A behavior that suggested the interior of 3I Atlas wasn't inert. It wasn't collapsing. It wasn't cooling. It was doing something. Something no natural object should do. By the time dawn arrived, Deep Field Ghost had already created a visualization of the pattern. A time-lapse of the light curve compressing and expanding like the chest of a sleeping giant. He posted it privately to the Discord, and one line followed it. If this is real, it's alive in a way we don't understand. Hours later, half the members of the server reported receiving unusual login alerts. 2 had files disappear from cloud storage. 1 received a message claiming his IP was being monitored due to abnormal traffic. None of that stopped them, because by then the truth was clear. The first real breakthrough about 3I Atlas didn't come from a billion-dollar telescope. It came from a backyard. Silence is not the absence of information. Silence is information, the kind that carries weight, the kind that leaves a mark, the kind that tells you someone, somewhere, made a decision. And in the 48 hours after the amateur breakthrough, that silence spread like frost. NASA's daily updates, gone. Their public tracking dashboard, normally updated every few hours, froze at a timestamp that looked almost deliberate. 0217 UTC, the exact minute the first amateur Fourier transform started circulating privately. ESA's heliophysics division, unreachable. Their media line, usually automated with cheerful responses, redirected to a blank message. We are currently reviewing internal data. Please stand by. Reviewing internal data. A phrase that has no meaning unless the data doesn't behave. But the most chilling reaction came from the Mars Reconnaissance Orbiter team, the same team holding the unreleased high-rise close approach images. For the first time in weeks, they locked their entire image archive behind authentication. A researcher tweeted, "Server maintenance again?" The tweet vanished 10 minutes later. His entire account followed soon after. Then came the most suspicious moment of all. JPL's updated orbital solution, which normally reflects new data automatically, reverted to an older version. Not revised, not updated, reverted, almost as if someone rolled the clock backward. A quiet reversion is more revealing than a loud announcement because it tells you what they don't want you to see. The drift, the pulse, the shift, the anomaly. The amateur community noticed instantly. One user wrote, "They're pretending the last 36 hours didn't exist." Another added, "If the official numbers don't change, we're expected to believe the object stopped changing too." But the object didn't stop changing. The sky never lies. As agencies descended into wordless retreat, telescopes across the world, the small ones, the forgotten ones, the ones no institution bothered to censor, kept seeing the same thing. A shift in the hue, a subtle restructuring of the coma, a persistent rhythmic flicker buried inside the nucleus. Meanwhile, internal leaks began to surface, small at first, but undeniable. A technician from an ESA-affiliated observatory wrote anonymously, "We've been told to hold data releases, no explanation." A NASA contractor posted on a private forum, "There is disagreement inside. Some think the object is exhibiting non-natural periodicity." That phrase alone has started arguments. Non-natural periodicity. It's not a claim, not an accusation, not a theory. It's a category, and one no agency wants to tick accidentally. But the loudest silence came not from NASA or ESA, but from an institution that almost never addresses the public anyway, the Deep Space Network. For 3 days straight, DSN stations reported scheduled downtime at the exact times when 3I Atlas passed near their optimal receiving windows. Scheduled downtime during an interstellar object's most active phase. One DSN operator wrote and then deleted a single post. "If we recorded anything, you'd never see it." Touchline. When every institution with eyes on the sky goes quiet at the same moment, it's not coincidence, it's choreography. But what frightened astronomers wasn't the silence itself. It was what the silence replaced, because silence means one thing above all. Someone thinks the truth is worse than the questions. Meanwhile, amateurs, the only observers still publishing without constraints, kept their lenses pointed upward. And that's when they captured something that forced even the silent agencies to look up again. A behavior so subtle, so delicate, so impossible that it threatened to break the story open. The event didn't arrive with a flash. It didn't roar across the sensors or tear through the data streams. It arrived gently, almost politely, like a whisper pressed against the edge of the night. At first, it looked like a calibration error, a faint realignment inside the coma. A soft ripple, subtle enough that half the amateur astronomers dismissed it as atmospheric distortion. But then it repeated, and the second time, it was sharper. A thin line of brightness tilted a fraction of a degree, no more than the width of a human hair held at arm's length. Yet the shift propagated through the entire coma like tension rearranging inside a suspended net. One observer in Argentina noticed it first. He wrote in his private log, "It's adjusting. That's the only word I have. Adjusting. Adjusting." Natural objects don't adjust. They react. They crumble. They deform. They do not self-correct. This shift, however, was purposeful. Not chaotic. Not random. Purposeful. An hour later, a second anomaly emerged. The coma's brightest region, the core of reflected light that should remain roughly centered, migrated ever so slightly toward the object's trailing side, only by pixels. But consistently, every 10 minutes the centroid moved again. Calm, steady, unhurried, like a spotlight rotating inside a fog. A researcher at a small observatory in Greece plotted these centroid shifts and noticed something chilling. The direction of the drift aligned with the object's previous deviations, the same deviations NASA and ESA quietly removed from their official datasets. He wrote a single sentence. "This is not external force, this is internal intention." He deleted the line, but not before someone archived it. Then came the micro-reveal, the detail that froze discussions across half a dozen private astronomy servers. The coma did not simply shift. It tightened. The dust halo, which should expand as material escapes into space, began contracting along one axis and expanding along another, not uniformly, not gradually, but following a curve too smooth to be natural, too elegant to be chaotic. The kind of curve you see when a gyroscope regains balance. Someone posted a simulation. Try spinning a sphere with uneven weight. The wobble disappears once it finds its correct orientation. And that's when the first serious hypothesis appeared. Not in a thread, not in a paper, but in a quiet message from a retired engineer who had spent 3 decades on spacecraft attitude control systems. "This looks like an orientation maneuver." The message was posted for 60 seconds. Then it vanished. But the idea had already spread. An orientation maneuver implies internal structure. Internal structure implies non-random behavior. Non-random behavior implies intention or design. No one said the word aloud. They didn't need to. Touchline. When an object from another star adjusts its posture, you should ask yourself whether it's reacting to us or preparing for something else. The fear wasn't that the object moved. Objects move. The fear was how it moved. Too gentle to be gas jets, too regular to be debris shedding, too coherent to be luck. The shift occurred again just before sunrise over Europe. This time more pronounced, enough to appear in frames taken with ordinary DSLR lenses. For the first time, the public could have seen it, if the platforms where the images were uploaded hadn't removed them instantly. 3 uploads. 3 deletions, different accounts, different regions, no explanation. Meanwhile, a cluster of professionals monitoring the object reported a strange sensation, one described as watching something wake up. Not wake up literally, not biologically, but mathematically. The object was settling, centering itself, regaining equilibrium not through nature, but through purpose. The pullback maneuver, if that's what it was, ended a few hours later. The coma relaxed, the brightness stabilized, the centroids stopped migrating. But the message had already been delivered to anyone with eyes to see. Something happened inside 3Is Atlas, something that required it to shift, correct, and realign. And whatever had changed had happened after it passed behind the sun. It began as a rumor, a single line buried in a chat room for deep sky observers. Did anyone else lose Starlock tonight? Most ignored it. Starlock failures happen all the time during bad seeing, or when passing clouds confuse tracking software. But then a second report appeared, then a third, then 14 more. Different countries, different longitudes, different sky conditions. Every report described the same unnerving thing. For several minutes, the stars drifted, not visually, not to the naked eye, but through the tracking systems. The very tools astronomers rely on to anchor the sky. The software couldn't hold on to the stars. It kept recalibrating, resetting, searching for reference points that refused to stay still. One amateur in Norway wrote, "My mount lost alignment for the first time in 7 years." Not the object, the background. Another added, "It felt like the stars blinked." At first, no one connected these failures to 3I Atlas. Why would they? Star drift and object anomalies live in different worlds, but then a professional astronomer quietly posted a chilling observation. The star field behind 3I Atlas shows positional jitter not present in adjacent fields. Positional jitter, the same kind of subtle distortion that appears when something passes between the observer and the background, something transparent or energetic or gravitational. It was the kind of anomaly you'd expect from gravitational lensing, except lensing requires enormous mass. Mass far beyond anything a small interstellar visitor should possess. Yet here it was, a tiny stretch, a barely perceptible ripple in the coordinates of background stars. A pattern that repeated only when telescopes pointed near 3I Atlas. One researcher from Japan wrote in a private memo, "It's not lensing, it's too clean, too localized, more like interference." Interference, a forbidden word in astronomy. Interference means a field effect, a distortion, an influence that should not exist in empty space. And that's when the second anomaly appeared. The stars didn't just drift. For a brief moment, 2 minutes, maybe less, many telescopes reported a drop in background luminosity. Not clouds, not equipment. A real, measurable dimming, a dimming that followed 3I Atlas as it moved, as if the object carried a shadow that wasn't a shadow. A veil, a distortion, a zone where starlight weakened by a fraction of a percent, too small for human eyes, too precise for coincidence. A European observatory logged it as localized stellar attenuation synchronized with interstellar object trajectory. But the log was archived internally, not released publicly. Touchline, when the stars dim, it's not the stars that are changing, it's what stands between you and them. Then came the micro reveal, subtle but devastating. Satellite imagery from commercial networks showed a similar flicker along the object's projected path. Not brightening, not darkening, a phase shift, a brief localized warp in luminance, like the pixels themselves hesitated. When someone posted a frame to the public satellite database, the image was replaced within minutes with a lower resolution version scrubbed of anomalies. The replacement looked cleaner. Too clean. The timestamp did not match the metadata. Meanwhile, amateurs kept reporting the same thing. For a moment, it was like the sky held its breath. A poet's description, but technically accurate. Because during that brief window, all background motion, cosmic noise, atmospheric wobble, scintillation dropped to near zero, as if the sky went still. Astronomers call this impossible. The atmosphere is never still. The stars never freeze. Yet they did, and the timing matched exactly to the second, with the moment 3I Atlas executed its unexplained coma realignment. For the first time, the object wasn't just behaving strangely. It was affecting everything around it, not violently, not dramatically, but unmistakably. A quiet influence, a displacement, a ripple in the fabric the stars sit on. When the logs were finally compared across observatories, the conclusion was uncomfortable. The night the stars went quiet was the same night 3I Atlas shifted its posture. Correlation isn't proof, but it is a fingerprint, and fingerprints tell stories whether we want them to or not. It didn't start with a bang or a flare. It started with a graph, a simple photometric curve that should have been boring, predictable, and forgettable. But it wasn't. A graduate student at a mid-tier observatory in Spain noticed it first. He was plotting brightness measurements for a routine nightly report when something strange caught his eye. The light curve wasn't random. It carried structure. At first glance, it looked like noise, faint rises and dips buried inside the usual scatter. But when he zoomed in, the noise resolved into small, repeating humps. Evenly, spaced, consistent, mathematically neat. He double-checked the timestamps, checked the calibration frames, checked the atmospheric logs. Everything was normal, except the curve. He wrote 3 words in his notebook. This is patterned. He ran a basic periodicity test, expecting a messy result. But the signal lit up with astonishing clarity. A consistent interval of 131 seconds. Light from natural objects doesn't pulse with that kind of cleanliness. Random processes don't honor perfect intervals. Something behind the brightness was beating. He hesitated before emailing the senior team. Before he could click send, the network crashed for 12 minutes. When it returned, the file containing the plot had corrupted. He didn't believe it was an accident. Meanwhile, thousands of kilometers away in Arizona, a group of amateur astronomers unknowingly discovered the same thing. They compared nightly brightness stacks and saw a soft flicker, rising and falling like a tide. They thought it was atmospheric distortion, until one of them aligned the exposures carefully and ran a frequency analysis. The pattern emerged again. 131 seconds. They tried a second data set, same number. A third, same. One of them joked in the chat, either my telescope learned how to keep time, or something else is doing it. But the joke didn't last long, because then came the micro reveal. The detail that turned a curious flicker into a seismic anomaly. The interval wasn't just repeating. It was modulated. Every 7th cycle, exactly every 7th, the peak didn't rise as high. Like a skipped breath. A deliberate pause. One observer described it best. It's like listening to a machine running a diagnostic pattern. A machine? They didn't say it out loud, but they all felt it. Natural objects don't create recursive modulation patterns. Random phenomena don't count cycles. Something was shaping the light, not by intensity, but by timing. One astrophysicist, analyzing the Fourier output, whispered to a colleague, "This isn't brightness, this is behavior." He deleted the recording of the call immediately. Touchline, when light carries rhythm, someone or something is keeping time. Meanwhile, the agencies finally responded, not publicly, but through subtle edits. NASA updated their photometric readings. The new dataset was smoother, cleaner, suspiciously perfect, missing the flicker entirely. Within hours, amateurs compared their logs to NASA's release and realized what had happened. The official data had been filtered to remove the pulse, filtered to remove the periodicity, filtered to make the object look boring. One amateur asked the question no one wanted to ask: why normalize the data unless the anomaly is real? Yet the light didn't stop. It continued through the night, rising, falling, breathing. A researcher in Canada plotted the pattern over several hours and froze when he saw it. The 131-second beat wasn't random. It wasn't self-contained. It matched a harmonic series, a mathematical progression suspiciously similar to calibration patterns used in orientation systems for spacecraft. He sent the chart to a colleague. The colleague replied with only one line: Where did you get this? Don't send it again. The pattern deepened. The intervals sharpened. The modulation stabilized. And for the first time, the object's flicker resembled something terrifyingly familiar, a controlled oscillation. Not a voice, not a message, not communication, but a function. Something was happening inside 3I Atlas, something rhythmic, procedural, almost algorithmic. The night it flickered with intention was the night researchers realized one truth. This wasn't a comet behaving strangely. It was a system performing a task. It arrived without warning. No watermark, no metadata trail, no signature. Just a plain text file dropped into a private mailing list used mostly by mid-level researchers who were growing increasingly uneasy about the silence surrounding 3I Atlas. The subject line was only 3 words: "You're not wrong." Most ignored it. Until they opened the attachment. Inside was a single page, a screenshot of what appeared to be an internal briefing slide. Not polished, not official, but undeniably real. It contained a tiny block of text at the top, a few lines of terse clinical language meant for quiet rooms and controlled audiences. Preliminary assessment indicates periodicity detected in photometric data is consistent across instruments. Pending classification, non-stochastic light modulation. Non-stochastic light modulation. The phrase hung in the air like a crime scene. A phrase that should never appear in reference to an interstellar object. A phrase that admits, without admitting, that the light is not random, that something behind the brightness behaves with purpose. Beneath the header sat a small, grainy graph, low resolution, cropped but unmistakable. The 131-second flicker, clear as daylight, labeled, tagged, acknowledged. The same pattern NASA had scrubbed from the public dataset. The bottom of the slide was partially redacted, blurred out, smeared digitally. But one line survived. Pending further review, recommend limiting external discussion until confidence intervals established. Translated, don't talk, don't leak. Don't let the public see the anomaly. The document spread like wildfire, quietly, silently, through locked channels and encrypted chats. It wasn't scandalous. It wasn't sensationalistic. It was worse. It was ordinary. The kind of internal memo agencies write when something is real but inconvenient. A scientist at ESA, upon seeing the leak, whispered the only conclusion that made sense. They knew the pattern wasn't noise. Minutes later, her message disappeared from the server, and then came the second part of the leak, the part that turned unease into dread. Another image. This time, not a graph or a memo, a photograph, low contrast, shot from inside what looked like a control room. A monitor displaying a brightened time-lapse stack of 3I Atlas. But the coma wasn't just flickering, it was forming something. A faint lattice, a skeletal grid of light and shadow extending from the nucleus in thin angular strands. Angular, not curved, not diffused, no natural process forms angles in a comet's halo. In the corner of the monitor, barely visible, was a timestamp. DSN-14 passive capture mode enabled. The Deep Space Network had been recording the light pattern, not noise, not residual heat. A capture mode, a term reserved for high-value data streams. Someone in that room knew exactly what they were watching, and someone else wanted that knowledge to stay contained. Within hours, the image vanished from every platform it touched. Links died, accounts disappeared. Servers purged their caches, but it was too late. Thousands had already saved it. The amateur community erupted. They compared the leaked lattice to the radial structures seen in earlier images. Some theorized resonance patterns, others saw geometric scaffolding. One whispered, "It's almost architectural," not meaning buildings, not meaning construction, but meaning design, intent. Touchline, when an agency leaks by accident, it's noise. When a leak appears this clean, this specific, someone wanted the truth to escape. The narrative shifted overnight. Before the leak, 3I Atlas was an anomaly, a misbehaving visitor. After the leak, it became something else entirely, an object exhibiting organized behavior, a structure generating patterned light, a body whose internal activity could no longer be denied or normalized. Professional astronomers, who had spent weeks avoiding speculation, finally said what they had kept to themselves. This is no longer a question of whether something is happening. It's a question of whether we'll be allowed to study it. Because if the periodic flicker was real, if the angular lattice was real, if the deep space network was capturing data in secret, then the blackout wasn't about caution, it was containment. The leak didn't answer the big questions. It didn't reveal origins or intentions, but it did something far more powerful. It cracked the wall. It proved that behind the curated datasets, behind the silence, behind the redacted releases, there was a truth someone didn't want us to see. And if this leak was real, what else had been buried? The first hint arrived buried inside a spreadsheet, a tiny column of numbers that should have been forgettable. A junior analyst at a Midwestern university noticed it while cross-checking orbital solutions for a class assignment. He wasn't supposed to be looking that closely. No one was. But he saw it anyway. The drift wasn't random. It followed a curve. A shallow, elegant bend. In space, too smooth to be gravitational noise, too deliberate to be dust jets, too precise to be solar wind pressure. At first, he thought it was a plotting error. He reloaded the dataset. Same curve. He downloaded the alternate dataset. Same curve. He plugged in the amateur coordinates from 3 nights earlier. The curve sharpened. He sat back in his chair. The shape wasn't familiar, but the behavior was. A slow, corrective deviation, matching the pattern of a planned burn. He hesitated before messaging his professor. "I think this object is performing active station keeping." The message was marked as seen. Then the professor went offline. Minutes later, the student's access to JPL's covariance files was revoked. That was anomaly number 1. Because natural objects do not station keep, they do not counteract solar drift, they do not flatten their orbital deviation curves with precision approaching spacecraft algorithms. But 3I Atlas did. Then came the second anomaly, deeper, more unsettling. A team in South Africa compiled 10 days of independent sky measurements and found that the object's trajectory wasn't just bending, it was converging. Not toward Earth, not toward Mars, not toward any obvious gravitational attractor. It was converging toward a region of empty space, a point with no mass, no body, no known feature of significance. One of the analysts whispered, "It's not falling toward something, it's meeting something." Meeting what? No one answered, because the third anomaly killed every mundane explanation in one blow. The trajectory correction was quantized, not continuous. Not smooth. Quantized, tiny stepwise adjustments in direction and velocity, too discrete to be natural, too consistent across instruments to be noise. Every 11 hours, the object shifted. A tap. A nudge, a correction. One astrophysicist described it perfectly. "It's flying on rails we didn't build." He deleted the comment immediately. And then the micro-reveal detonated, quietly, ironically, on a weather satellite. One of the GEOS satellites picked up a faint thermal anomaly in the region near the course adjustment. Not heat, not radiation. A signature, a smear of thermal displacement resembling a wake. A wake in the vacuum. Objects in space don't leave wakes unless they are interacting with something. A field, an environment, a medium we haven't identified. When a private analyst enhanced the frame, he found something no one expected. The displacement was directional. 3I Atlas wasn't drifting into its new path, it was pulling itself into it, like a magnet snapping toward a hidden rail. Touchline: if an interstellar visitor begins following a path that nothing in the solar system controls, then something else is guiding it. Finally, a leak appeared in the most unlikely place, a short-lived note on a late-night scientific forum, posted by someone claiming to work at an orbital. "Dynamics Division, internal meeting today. We can't explain the course corrections." Someone asked if there's an external reference point. The room went silent. External reference point. Not a planet, not a star, not a gravitational source, a coordinate, a destination. And suddenly, the earlier anomalies, the pulse, the lattice, the coma reorientation, the localized star dimming, All began to feel like pieces of a larger pattern, because objects don't shift their posture unless preparing for a maneuver. They don't stabilize internal cycles unless sinking to something. They don't converge on empty space unless empty space isn't empty. The question was no longer, why is 3i Atlas behaving this way? The question had become, what is waiting at the point it's moving toward? On every star map, in every catalog, in every database used by professionals and hobbyists alike, the coordinates meant nothing. Just blank space. A quiet, empty region with no stars, no dust clouds, no gravitational anchors, no known objects of interest. It was a cosmic void, the kind astronomers skip past without a second thought. And yet, that was where 3i Atlas was going. The first person to publicly identify the coordinates, before the post vanished, was a Chilean amateur astronomer who plotted the convergence point using a simple least squares method. He wrote, "It's heading toward a place with nothing in it." 5 minutes later, the comment thread disappeared. His entire account followed. But the coordinates were saved by someone else, and someone else, and then someone else. Soon, private astronomy channels buzzed with the same question. Why would a visitor from another star aim for emptiness? The theories fell into 3 categories. Theory 1, a debris field. Some suggested a hidden cloud of micro-objects, too small to catalog, too scattered to detect. But debris fields don't pull objects, they don't guide trajectories, they don't create quantized course corrections. Theory 2, a magnetic anomaly, a localized bubble of interplanetary magnetic turbulence. But interplanetary fields are chaotic, violent, unpredictable. Atlas moved with elegance, not chaos. Theory 3, a point of reference, not a destination, a calibration point. Like a lighthouse that emits no light. A silent marker, a fixed coordinate used only by something that already knows it exists. The moment that theory appeared, everything changed, because hidden inside the coordinates was the first micro-reveal. A PhD student in Italy overlaid the convergence point onto archival spacecraft navigation charts, the kind normally ignored by the public. Her message was brief. Why does this coordinate appear in a decades-old DSN calibration file? That file, quietly buried in deep archives and listed fixed points, used for old signal timing tests. Places where nothing exists, chosen because nothing exists, but the coordinates match down to 6 decimal places. Why would an interstellar object navigate toward a point used in human calibration tests? Coincidence? Impossible to know. But the coincidences didn't stop. A researcher in India overlaid the same coordinates on ancient sky charts, medieval star maps, Babylonian tiles, Vedic astronomy plates. One of them, a fragment of a Sumerian tablet, marked the empty region with a symbol meaning, the gate where no stars speak. Another coincidence. Or something older. Something forgotten. Something we stopped paying attention to centuries ago. Then came the second micro-reveal, one that didn't come from amateurs at all. A technician from a commercial satellite company leaked a screenshot of a system alert from the previous night. Untracked object detected near reference point. Signal scatter profile inconsistent with debris. Untracked object, near the same point, but invisible to optical instruments. When analysts enhanced the scatter pattern, they found the faintest echo, not a shape, not a reflection, but a distortion. Something was there. Something small. Something dark. Something that bent light without reflecting it. A silent presence. The technician was fired 2 days later. The company released no statement. Meanwhile, the object's trajectory tightened again, the clearest, cleanest correction so far. Not a drift. Not a wobble. A direct move. Like a key aligning itself with a lock, touchline, when an object from another star heads unerringly toward a point we long believed was empty. You have to wonder if the emptiness was the lie. Finally, an independent researcher from Australia published a simple but devastating calculation before the post was removed. The time of arrival. If 3i Atlas maintained its current correction pattern, it would reach the coordinate in 43 days. 43 days until the convergence. 43 days until the meeting point. 43 days until the empty space proves whether it is truly empty. And for the first time, a chilling possibility emerged across every private chat, every encrypted channel, every terrified voice message. Maybe that point in space doesn't matter to us, but it matters to it. It began at 0412 UTC, not with a flare, not with a pulse of light, not with anything visible to the human eye. It began with a hiccup, a tiny, almost insulting disruption in the radio spectrum. So small that half the receivers ignored it. So clean that half the analysts dismissed it as ground interference, a spike, narrow to precise, barely rising above the noise floor, a single thread of energy at 1.402 GHz. Most people don't know what that frequency represents, but astronomers do. It's a region adjacent to the hydrogen line, the universal reference point for interstellar communication attempts. A place in the spectrum no natural object should use, no comet could generate, and no drifting rock should ever touch by accident. And yet the spike was there. At first they thought it was terrestrial. Reflections from satellites, airport radar interference, military chatter bleeding into the band, until the second spike arrived, this time at observatories thousands of kilometers apart. Within the same half-second window, Chile detected it, then South Africa, then Australia. 3 stations, 3 hemispheres, 1 signal, and then something happened that froze the entire scientific community. The signal was Doppler shifted exactly as it should be if it originated from 3I Atlas, not from Earth, not from a satellite, not from a passing plane, from the interstellar object itself. A senior engineer at a radio astronomy institute ran the correction manually and whispered, "It's moving with the object. It's tied to its velocity." But the real shock wasn't the frequency. It was the pattern. The signal wasn't continuous. It was pulsed, and the pulses matched with frightening accuracy the 131-second brightness modulation detected in the light curve. Light flicker, radio flicker, same rhythm, same timing. The graduate student who discovered the light pattern wrote in disbelief, "It's the same heartbeat." But the heartbeat had a new twist. Every 7th pulse in the radio signal dipped, the same skip seen in the brightness cycle, the same pause, the same breath. This was not coincidence. This was coupling, the light and radio domains linked by the same internal process. Natural comets do not link optical and radio emissions. Not with precision, not with rhythm, not with mathematical regularity, but 3I Atlas did. For the first time, professionals began to panic, not publicly, never publicly. But in private messages, closed forums, encrypted calls, scientists admitted what they had never dared to voice. This is activity. Not noise, not jets, not scattering. Activity. Then came the micro-reveal, the detail hidden within the pulses. A PhD candidate in Canada fed the signal into a waveform analyzer, expecting static. Instead, she found harmonics, faint, structured, evenly spaced, not information, not a message, but a scaffolding, like the frame of a carrier wave, a foundation on which information could be placed. She posted her findings privately. "This looks like an initialization sequence." Minutes later, her university's network access was suspended. Meanwhile, in a small observatory in Finland, a technician captured a strange sideband structure, a faint tail on the pulse, like an echo. Not an Earth echo, not a satellite bounce, an intrinsic echo. Something inside the object was reflecting or modulating its own emission. He enhanced the signal and found the echo delay remained constant, 14.8 milliseconds. The distance implied by that delay was small, absurdly small, roughly 4,400 kilometers. Something was reflecting the pulses. But nothing existed at that distance, not a moon, not debris, not a cloud. The echo came from empty space, or what we thought was empty space, touchline. When light and radio begin beating to the same rhythm, something is coordinating the breath. The panic grew not because of what was heard, but because of what wasn't heard. NASA issued no statement. ESA issued no statement. The Deep Space Network went silent, but a single leaked line from an internal meeting slipped out before the server logs vanished. "Do not respond to the signal." Respond? Respond to what? The pulses weren't communication. There was no encoding, no message. Not yet. But buried inside the harmonics was a chilling truth. The signal wasn't directed at Earth. It wasn't searching for us. It wasn't calling to us. It was syncing, aligning itself, calibrating. To the same point in space, the object was heading toward the empty coordinate that should not matter. The signal wasn't a message. It was a handshake with something waiting in the dark. The first people to notice it weren't the agencies, the observatories, or the academic institutions. It was the amateurs. Always the amateurs. A man in rural Canada plotted the radio pulses from the last 5 nights and saw it first. Not the frequency, not the harmonics, not the echo. He saw the spacing. The 131-second interval wasn't drifting randomly the way natural oscillations do. It wasn't tightening or loosening the way thermal processes behave. It was shortening. Not by much. Fractions of a second at first. A microscopic trim. A tweak so small, most systems filtered it out as jitter. But when plotted over time, the pattern revealed something chilling. The interval was decreasing at a constant rate, a linear contraction, 131 seconds, 30.994.130.987.130, 981. Each night, a small cut, a rhythmic tightening, a system pulling itself into alignment. He posted the discovery to a private astronomy board with one terrified question: is this a countdown? The post vanished in 4 minutes, but it didn't matter. Others had already seen the same contraction. A doctoral student in Denmark confirmed it. A radio technician in Chile confirmed it. A retired physicist in Thailand confirmed it. The pattern was universal. But here was the part that broke the last of the doubts. The shortening interval matched the object's projected arrival at the empty coordinate, the silent point, as the community had begun calling it. As 3I Atlas approached the point, the beat sharpened, just like a spacecraft narrowing its timing lock, just like a probe preparing rendezvous, just like systems synchronizing before contact. That was anomaly 1. Then came anomaly 2, the brighter, louder, impossible to ignore anomaly. At 0241 UTC, telescopes across the world recorded a sudden, gentle tightening of the coma. Not collapse, not shedding, a focusing. The dust halo contracted along the same axis the light pulses were aligning to, like a lens being cleaned, like an iris, sharpening. For a brief moment, only 49 seconds, the nucleus glowed with an unnatural clarity, revealing structure inside the coma that defied every model. Striations, bands, geometric cross-threads. And then the clarity vanished, the images were pulled, the archives wiped, the observatories issued correction statements blaming sensor issues, but dozens of screenshots survived. Every screenshot showed the same thing. The object wasn't getting brighter. It was getting organized. Then anomaly 3 hit, the one that changed everything. A cluster of weather satellites completely unrelated to astronomy reported false positives in cloud temperature sensors over oceanic regions. The readings were off by tiny increments, tenths of a degree, but the anomalies formed a pattern that matched the 131-second contraction timeline. Someone stitched the anomalies into a time-lapse. The thermal shifts moved like ripples, away from the silent point, not toward us, not toward the sun, not toward the planets. From the coordinate, as if something at the coordinate was preparing for arrival. The implications were unbearable. Something out there was sinking. Something out there was responding. Something out there was waking. Agencies finally reacted, not with statements, but with locks. NASA's orbital dashboard, down for maintenance. ESA's deep sky logs, archived without explanation. The Deep Space Network, completely offline. Not for minutes, not for hours, for days. A leaked internal message from someone claiming to be inside DSN simply said, Phase 2 initiated. Expect blackout. Blackout, not a communications failure. A decision, touchline. When timing becomes too perfect to ignore, you're no longer observing nature. You're watching a sequence. The countdown accelerated, 130.981 seconds, 30.974.1 and 30.967. By midnight, Analysts across private channels agreed if the contraction rate continued, the pulse interval would reach a round perfect number in 6 days. Exactly 6 days before 3I Atlas reached the silent point. A perfect lock-in, a synchronization event, a rendezvous. Whatever was happening, whatever was responding from the point in space, no one believed mattered. It wasn't waiting for impact, or orbit, or arrival. It was waiting for timing. The amateurs whispered the terrifying phrase first. This isn't a countdown to collision. It's a countdown to connection. And if the math was right, we were running out of time. No one slept the night the interval crossed 130.960 seconds. The shift was microscopic, irrelevant to the public, invisible to the news, undetectable without specialized software. And yet every person who had been following the data felt it like a tremor under their feet. The beat was tightening, the light was sharpening, the object was aligning, and the sky, for the first time in human memory, felt like it was holding its breath. By now, the amateurs, the researchers, the anonymous technicians, the obsessed loners with $400 telescopes, they weren't just looking through lenses anymore. They were listening, feeling, waiting, because every sign pointed to an unavoidable truth. Whatever was happening above us was not random. It was not spontaneous. It was not silent. It was deliberate. And every step, the tightening pulses, the synchronized radio echoes, the trajectory corrections, the coma contraction, had led to one unavoidable moment, a decision point, not for the object, for us. The first sign arrived just after sunset over the Pacific. A small observatory in Hawaii reported an unexplainable flare in the dust halo, not brighter, not hotter, but sharper, like someone turned the focus dial on a cosmic instrument. Seconds later, instruments in Chile detected a faint echo on the hydrogen line, not from the object, but from the silent coordinate itself. 2 echoes, 2 signatures, 2 pulses, matched within 1,000th of a second, like 2 clocks syncing, like 2 systems linking, like 2 presences acknowledging each other. A researcher in Argentina wrote, trembling, "Something just answered something." Then, chaos, data streams spiking, sensors saturating, weather satellites catching phantom shadows, ground telescopes reporting brief, impossible clarity in their images, clarity so sharp it couldn't have come from Earth's turbulent atmosphere. For a moment, just a blink, the sky behaved like the vacuum of space. Still, silent, focused, the kind of atmosphere one would expect if something were exerting pressure, or counter-pressure, or a stabilizing field. And then the moment passed, but the implications didn't. Then the final anomaly dropped, quiet, modest, devastating. A group of amateurs comparing brightness curves found something unreal. The 131-second interval, the pulse that had been shrinking for weeks, the heartbeat of the object had stabilized, not increased, not decreased, stabilized to a perfect, impossibly clean interval, 130,000 seconds, exactly. No drift, no variation, no turbulence. A perfect number, a chosen number. Every analysis agreed. This was no longer a contraction. It was the final lock. The system, whatever system existed inside or around 3I Atlas, had finished its synchronization. 5 days before arrival at the silent point. 5 days before whatever was hidden there would meet whatever was arriving. 5 days before 2 unknowns touched. And with the lock came something no one expected. Silence. Not from the agencies. They had been silent for weeks. Silence from the object. The radio pulses stopped. The brightness modulation flattened. The anomalies froze. The object became perfectly, impossibly still. Not dead, not inert, not cooling, just ready. A technician in Japan described it in one sentence: "It feels like the sky is waiting for us to notice something." And then came the final micro-reveal, the one small detail that changed how every person who saw it interpreted the entire event. A lone amateur in Poland enhanced the final pre-lock exposures and found a faint structure inside the coma, a thin curved line, almost like a boundary, almost like an opening. He wrote, "If this isn't a trick of light, then the object isn't preparing to hit the coordinate. It's preparing to dock." No one knows if he was right. No one knows if we ever will. Touchline. At some point, You stop asking what the object is. You start asking why it chose now. And that became the final, unbearable question. The question the sky forced every one of us to confront as the countdown reached its lock. Are we witnessing a coincidence of nature, or the first step in a process we were never meant to see? There is no answer yet. Only the ticking. Only the waiting. Only the knowing that 5 days remain. And as the world looks upward, divided between fear and hope, denial and obsession, one truth has never felt sharper. We are not in control of the next chapter, but we are witnesses. And sometimes, in the vast, silent ocean of the cosmos, being a witness is the most terrifying role a species can play.